Hello everyone, welcome to IT Crowd Pack Stocks. And today we will continue with our next journey of Pi, who will now deep dive into list. We will today look into what are lists, then definition of list, what are the built-in functions that are available in the list, methods available in the list, as well as how you can do copying and deep copying in the list. And to continue, what we have designed today is to have a complete beginner to intermediate level of understanding about Python list, including its characteristics and list methods. And also there are some exercises that will be followed. To start with, let me just introduce you to the definition of list. List is nothing but the ordered collection of mutable elements which allow duplicates in it, and it is enclosed in the square brackets. Now we can have a understanding of each word separately. Ordered means what? Lists are ordered, means they can have a indexing operations in place. Lists are mutable means what? Each element can be changed or additional elements can be inserted in the list. List can allow duplicate means uh, set doesn't allow duplicate, however list can allow duplicates, and it is enclosed in square brackets. That is how you can identify Python list. Real life example would be a shopping cart, student attendance, employee records, playlist. That is how you can compare the list with real life examples. Now let's start creating empty list. Let me have my collab open. The reason I'm using collab is it becomes easy while traversing from theory to practical, and I will be able to demonstrate you some coding as well. So let me just create an empty list. L1 is equal to empty list. So we can just check type of L1. It will say list. ID of L1 can also be checked. It will provide you the ID of L1. So we have just created an empty list. Let's form a list using string. So I'll type a variable name, and I can just use list function, and I can say Python. Now if I am printing A, you can see each element of this particular string or each character has been taken into the list and it is separated using comma. You can also create list using tuple. Say I'll take another variable B, list of say 1 comma order comma. Here if I'm giving text, I'll have to write double inverted comma as well. Then I can just say 5.63, then I can say true, etc. So if I will check B, it will just print a list as it is. So I can convert tuple into list. I can also add set into list. You can just say variable C is equal to list of set 4 comma 5 comma 8 comma 9 comma 6 comma a 5.6 comma true comma test. And if I will print C, a unique thing that you might have noticed here is I have given set that will convert into list. However, I have also given multiple elements in the set which are repetitive, that is 8. However, while converting into list, it has taken 8 only single time, since set only contains unique values. You can also use range to convert into list. So I'll just define one more variable d as list range 10. And if I print D, you can see 0 to 9 it has printed and index excluded. So that is how you can create the list. Now, what are the characteristics of the list? Lists are ordered collections. That means if I want to access some element of the list, I will be able to access the element of the list using indexing. Say I want to access fifth element. So if you can see 0, 1, 2, 3, 4, 5. So fifth element I am able to access. Now if I want to access minus fifth element, that is also I will be able to do. Minus 1, minus 2, minus 3, minus 4, minus 5. If I can just say minus 1, it's ninth element, right? So that is why lists are ordered. Lists are mutable as well. Suppose D of say 1, which is D of 1, if I want to change to 50. Now we can see D of 1, which was 1, now has been mutated to 50. So lists are mutable. Coming back to next, allow duplicate values. So if we can see here, D of say fifth element, I can add it as 50 again. Since it allows duplicate values, you can see 50 is repeated. Next is dynamic sizing. So list has a dynamic sizing. For example, if I'm using for I in Python, I'll just define L1 as empty list, append L1, print L1. Say append I, and if I am giving print L1, so just check what exactly is the error in this. So I just understood what exactly is the issue. So it is, I should have given L1 dot append I. That means this I is traversing through Python and I want to append it to the list L1. So now if you can see, Python is appended into the list. So that is how it is dynamic in size. So if I am saying here I am in love with Python programming. Now if you can see, it has appended the entire thing. So size is dynamic in nature. It has a heterogeneous data. Means if I am say defining a list with integer, again I'll add float, I'll add some test text, say test, I'll add tuple here, 5, 6, 8. I can add set here 5, 6, 7. I can add dictionary here as name, number, 3, comma, and I can also add list into list. That will be a nested list. So this is how I can add different elements in the list. That's why lists are heterogeneous in nature. Now you can see the list is like this. Supports nesting, which I have already told you. Index operations are possible. Say L1, I'm saying give me L1 minus 1. It will provide me 568, which is last element in the list. It is iterable. This is iterable as well. For I in L1, print, if I'm saying I, now you can see all the elements are separated. I have just traversed through the entire list and I have taken out in each element separately. So lists are traversable, so iterable. Now accessing the elements in the list, you can access the element in the list using positive indexing as well as negative indexing. Positive indexing starts from forward, that is 1, 2, 3, 4, 0, 1, 2, 3, 4 like that. Negative indexing is from last element will be indexed as minus 1, minus 2, minus 3, minus 4 likewise. Slicing is also possible in the list where you will have to give start index, stop index and step size. Suppose if I want to store L2 as a list, say L2 equal to L1, I can give start index as 0, end index as say 6 and step size as 2. Now you can see, I should give colon. Now you can see I can just print L2. It has taken the first element as 1, which is at the 0th index. Then it has taken second element, which is after step size 2, that is 5.6. Third element it has taken 568, which is at fifth index, and sixth index is always excluded considering end index. So that is how start, stop, and step size can be used. Now lists can also be reversed. Say L1 colon colon minus 1. If I type, you can see the list is reversed now. That is how I can reverse the list. Negative step size also you can provide to the list. Say L2 is equal to L1 into minus 1, comma, minus 1, colon, minus 2. Now if you print L2, it will provide empty list. Huh. Now you can see I have started from minus 1, I have ended to minus 5, and I have given minus 2 as a step size. So from the reverse, if you see minus 1 element has come, this element has come, but after this, fifth index is ex last index, so it has given two elements. Now if I say 8 and if I print L2 again, I will have some additional elements in place. So that is how negative step size will also work. Reversing of the string we have already seen. Updating the list with single element with index. So you can update the element in the list. Say if I am printing L2, I know these are the elements, and if I say L2 of 0 equals to say 5.5. Now if you can print L2 again, you will see the first element, which was 568 as a list, is got appended to 5.5. So that is how you can update the single element. Multiple element in the list can also be updated using start index, end index, and equal to operator. Suppose I have this is what L2 looks like. If I say L2 give start index as 0, end index as 3, and uh, I'll just update it as say 1, comma 3, comma 4. Now if you can see L2, we have these elements 1, 2, and 1, 3, and 4 has been updated in place of 0th index, first index, and second index. Third index is always excluded. So 5 is as it is. So that is how you can update multiple elements as well. Now let's understand what are the different me methods available in list using different characteristics of those methods. First is adding elements. So when I have this L2 list which is there, so I want to append it. L2, if I say L2 dot append, and I say value as 56, you can check. Now this L2 has the last element appended as 56, right? I can also say L2 dot append L1. I can give additional list as well, which was previously created. Now you can see L2 has been appended with the list. So you can append anything in the list. Insert, let's see insert operation. L1 dot insert 5. So here you give index comma 25. So now you can see if I'm printing L1 here on the fifth index, I should have 25 appended, inserted. So insert inserts the value at a particular index, whereas append will append the value at the last index. Now we can just check what extend does. L1 dot extend extend L2. If I'm doing this way, you can see now this L1 list got extended with L2 list. So this was earlier L1 list, it got added L2 list. Print L1. Now if I print L1, this is how the list looks like. So this is how we can extend the list. You can also add elements in the extend. Now if I print L1 again, now if you can see, it didn't add nested list, whereas it added only the elements in the list, that is 5, 68, and 89. Although I gave list to extend, so it is just extending the original list. It will not add additional list in the previous list. So that is how extend differs from append. Now let's understand concatenation using plus operator. Say I have L1 list equals to, I'll define one more list 5, 6, 8, 9. I'll add one more list over here L2 as say 5, 8, 9, 10. These are the two lists I have created. Now I will just add L3 is equal to L1 concatenate L2. And if I print L3, you can see both the lists have been added. So concatenation is possible. Now multiplication. Now let's define L1 is equal to new list, which is, say, we can define heterogeneous list test, comma, say 5, comma, 5.6, comma, some additional tuple elements, say 5, 6, 8, comma, some boolean elements, true. Now I'll just say L2 is equal to L1 into 5. Now if you see, if I'm printing L2 list, the items in the L2 list will be repeated 5 times. So this is called replication as well. Now you can see this is the first element, this is the second, this is the third, this is fourth, this is fifth. So elements of L2, L1 elements have been repeated 5 times. So this is called replication and it is done using asterisk. Now we will understand what exactly we use for removing the elements from the list. So this is also very important when we are removing the elements from the list. I'll just define one list. L1 is equal to say 1 comma 5.5 comma true comma test. Now first is the remove function that we have. So here if I say L1 dot remove and I give value as true. So what it does is in L1 list it will find whether there is a true or its value is present or not. Since 1 is there, so it has removed true is equal to 1. Since value of true is 1. So if I say true true, then you can say bool of 1 is true. So that is why 1 is removed. Instead of true, if I say remove 5.5 and if I say check L1, 5.5 is also removed. That is how remove works. Now we will check how pop works. Now in pop, let me define the list again. I have defined the list again and I say L1 dot pop and I don't give any value or any index. What pop does is it will remove the last element. Now if I say L1 dot pop and I give index as 2, then it will remove the second element in the second element at the index, that is 0, 1, 2, that is true, it will remove. So now if I reprint the list, so this is how it is. Now the difference between remove and pop is remove works on value whereas pop works on index, and if the index is not provided, the pop will remove the last element. Now if I want to delete the list, so L1 dot delete, if I say delete L1, now you can see if I try to check whether L1 is there or not, it is going to delete entirely the existence of that particular list. Okay, so the difference between clear and delete is it is absolutely going to remove L1 variable itself. So the existence of the list is removed. If I say L1 is equal to 1, 5, 6, now you can see type L1 is list, ID of L1. You have something stored in a memory, right? So you have all these things are present for that list. Now if I say delete L1 and I run type L1, you will get the error because L1 variable itself is now deleted. So single, multiple, entire list. So entire list we have seen. Now if I have L1 equal to, I will define list, say 5, 5.6, 8, 6, and if I say delete L1 and I give some index, say 0 colon 2, and I say L1. Now if you can see, zeroth element is deleted, first element is deleted, second element will not get deleted because end index is excluded, so last two elements are still there. So that is how delete operation works in multiple. Single also you can do, if you can give single index over here, if I give 1 here and if I reprint L1, now the first index, that is 6, has been deleted. Now let's see if I have L1 equal to test comma true comma 1 comma 0 comma 5.6, and if I clear the list and I say L1 dot clear, and if I try to print L1, you can see it will not have any element. All the elements in the L1 list are cleared and it is empty list. Let me just redefine the list again and we can just check what happens in these functions. This is how you can also add multi-line string and you won't get any error while executing the cell. Okay, now let's count the number of elements in the list. So L1 dot count will give you number of elements in the list. So if I'm using index, I can still find the index of particular element in the list. That is L1 is equal to, I have defined this, and if I'm trying to find the index of 0, it is at the place of third index. Now let's sort the list. If I want to sort the list, I will define one more list in order A, comma, G, comma, T, comma, U, comma, E, comma, J. Now if I say L1 dot sort, and if I print L1 again, now you can see the elements in the list are sorted. That is A, E, G, J, T, U based on the value. If I say reverse, and if I print L1 now, you can see the list is reversed. Difference between sort reverse is equal to true and reverse, I'll just tell you. Now if I am defining L1 equal to 5, 6, 8, 9, 11, 58, 45, 78, 1, 25, 6, 14. Now if I say L1 dot sort and I give some argument as reverse equal to true, and if I print L1, now you can see these elements are sorted and they are in the placed in the reverse order. And if I say L1 dot reverse, and if I give this command, it will just reverse the list and it won't sort it. So in the earlier list, if I give reverse, now you can just see the difference. Here the list is only reverse, that is 14, but it is not sorted. Whereas in sort reverse equal to true, the list is first sorted and then again it is reversed. So that's the difference between sort and reverse. So far we have learnt append function, extend, insert, remove, then pop, clear, then again copy, count, index, reverse, and sort. So built-in function we have these built-in these all built-in functions which are there in string, they also apply and work in list as well. So if I'm defining some list, say this one as L1, let me just pull L1 here again, and now I am applying these built-in functions. Say L1 dot length. So in list L1 there are 11 elements. Now if I say max of L1, now it will check all the elements and it will give the maximum number which is there in that particular list. Say I'll say min of L1, it will provide me the minimum value in the L1, that is 1. If I can say sum of L1, then it will sum all the elements in the L1 list and it will give you the summation. Then if I say L2 dot sorted L1, and if I bring L2 here, you can check L1 is got copied into L2 list and all the elements in the list are same in the sorted order. Now any and all will give you true. So we can just check how we can use L1 dot any, and if I give 5 as number, so this I'll have to check how we can use any and all, enumerate, zip. Reversed we have already checked, reversing the iteration. Map filter function we will see when we will learn pandas and numpy. Now membership operator, concatenation we have seen, replication we have seen. There is membership operator that you can also check. For example, if I have a L1 list which is defined, say, let's take this list and define it over here, and I can just check in or not. Okay, if I type here as false in L1, and if I check, so false in L1 will give you false because we don't have zero or false in it. If I say test, so it will check and it will give you false. And the same way, if I type not in, it will give you true. Now then compare concatenation replication we have seen. Now comparison operator. Say I have defined L1 equal to 568, L2 equal to say 3 comma 6 comma 8. Now if I say L1 equal to L2, it will give me false. Even if I keep the elements same, still it will give me false. Reason is, although presently it is giving me true because all the elements in the list are same. However, lists are always mutable elements, right? So the idea of those things are those lists will be different. So here I can also check not equal to operator. So both the things are not equal. I can check whether L2, L1 is greater than L2. That is also false. If I can check L1 is less than L2, that will be true. In the same way, less than or equal to, greater than or equal to will also work as expected. This is how you can use comparison operators. Now, iterating through the list, you can also traverse through the list as I told you, right? So if I am defining a new list here, and if I say for I in range 5, sorry, for I in L1, for I in L1, print I have successfully traversed through the list. Now you can see this particular statement will get printed one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So now that is what it is happening. Now you can see it has been printed 11 times. So that is how list traversal does. You can also use while, enumerate and range function in the iterating the while iterating the list. L1 equal to range of 1 colon 10 step size 5 step size 2. Now if I type L1, now you can see 5 elements are present with the step size of 2. That is how you can use range as well. L1 equal to, if I am defining empty list and I'll define one count equal to counter equal to 1 while counter is less than 5, L1 dot append counter. Counter, you need to increment the counter so that it will check this condition and print L1. Now if I run this condition, you can see 1, 2, 3, 4 has been appended since I am appending the counter only. So that is how you can use while as well. This is to create the list. Again, you can also traverse through the list as well. Now we will study about copying. This matrix operations you can use depending upon definition of L1 equal to, suppose you have these kind of lists wherein you have defined matrix structure like 1 comma 2 comma 3, close this list comma, then 3 comma 4 comma 5, close this list comma, 5 comma 6 comma 9, and again you close this structure. So this is a matrix. And now if you print L1, it will print something like this. Right? So that is how matrix you can check. Now if you want to access the rows, you can just type L1 into bracket first element colon second element. Now you can see it went into this particular list and access the second element. That is how you can do. You can also access individual element in that particular second list. So that we need to check how we can do that. and you can have also access individual columns in the list, and you can have a nested loops as well. Now let's understand what is the difference between copy, shallow copy, and deep copy. There are different functions in which you can copy the list. Easiest method to copy the list is, say I have L1 equal to 1 comma 2 comma, I will have nested list in place 5 comma 6 comma 8, and now if I copy L2 equal to L1, now this will copy the entire L1 element into L2 element, and if I can see L2 is equal to this list. Now if I do L2 and I change some element, say I change the third element, the second element to 5, and if I check L1, it will remain as it. So L1 and L2 both are changed. So this equal to operator, what it does is it will change the L1 as well as L2. The original list will also get changed. So that is what this operation does. Now if I say I have one more list L3 equal to 5, comma 6, comma 8, and again one nested list. Say this is the nested list I have, and if I say L4 dot copy L3, L4 equal to L3 dot copy. So if I now check L4, all the elements are present. Now if I modify L4 dot with the index, say I am modifying the third index element to 5, now you can see L4 as this particular list wherein the third element has been changed, and if I go to the original list L3 remains as it is. So this is what copy does. Here if you can see equal to did copy the list, however both the original list as well as the copied list, if I change one element in the copied list, the same element in original list also gets changed. The reason is these nested lists are shared between these two elements. That's why it happens that way. Whereas in copy, if you see, I have this L1, I have this L3, I have this L4, wherein all these elements are separately carted. That's why if I change something in L4, it will only applicable to L4 only, and it won't be changed in original list, that is L3. That is what copy does. Now we will see what happens if I say copy dot copy. I will define L3, L4 equal to copy dot copy L3 dot copy dot copy. So I just figure it out why this is not working appropriately. We can just check copy.deep copy. So here we understand the difference between shallow copy and deep copy. So we will just check how exactly it works. In step one, you have a original list, that is student underscore marks. This is how it is stored in the memory illustration. Student marks, the outer layer stores separately, and inner layer, that is nested list, gets stored separately. Notice that the third element is another list, which is a nested list. Now case one is equal to operation. When I am saying list 2 equal to student marks and list 2 both will point to the outer layer, whereas inner layer will be stored separately. Now the argument is when both the variables point to the same object, must modify list of 0. If I modify it as 100, you can see both the lists are modified, whereas both the variables refer to the same list. Think people sharing same notebook and both the notebooks are modified. That is how equal to operation happens. Now in case of shallow copy, copy 1 student underscore marks dot copy 1 is equal to list student marks. This is how you can also do. Now you can just check what happened. Here you have to import copy. So this was the thing which I missed. That's why we were not able to use copy.copy. So if I would have imported copy library, then I would have not have an issue regarding which this I had. So I'll just do one thing, import copy. Now that I have imported copy, and I'll just run this L3 again, and I'll try creating L4 as a list. Now you can see it will work, and if I just check L4, this list is copied. Now what happens here is student marks, the outer layer gets copied. However, the inner layer, which is nested list, will have shared location. Now, outer list is copied, but the nested list is shared one. If I modify the outer list, that is, say, outer L3, say L4 of 1 equal to 256. And if I can check L3 and L4 elements, you can see the original list is not affected, whereas the nested list, whereas the second list which we copied now is having 256 instead of 6. That is how this particular thing works. Original list will be unaffected for the outer list. Whereas if we try and modify the nested list in the same way, say I have L3, L4, and the nested list is at 0, 1, 2, third index. So if I type 3 here and if I modify it to test, now you can see L3, the inner list, and this L4, the element in L4 got modified. Original list remains unaffected. That is how this particular thing happens. Now if I say L4 equal to copy dot copy L3, and if you see L4 and L3 are the same copy of each other. Now if I try and modify single element of that particular nested list, that is L4 first element, I will change it to 25. Okay. Now if I print L3, you can see even in L3 we have this particular element which is changed in spite of the fact that we only tried to change element in L4. Since this nested list has a shared location, that is how it will happen is in L3 if I am changing, L4 if I am changing, it will get affected to L3 as well. However, in deep copy, that is the case 4, say if I have L4 is equal to this, and if I am creating L5 equal to copy dot copy of L4. Now let's change some same element of L5 to 256, 526. Now if you can check L4, the original list remains unaffected, whereas in L5 we have changed one element, that is 526. So that is how deep copy functions, in which the memory illustration is outer layer and inner layer. That is, all the layers are stored stacked separately. That is how if I change something in one list, that won't affect the other list. If I change something in other list, that won't affect the original list. So that is the difference between copy and deep copy. So you can just check in assignment, new outer list, nested list is copied. No. Nested objects shared, yes. Changes the outer list affects the original, yes. Changes in the nested list affect the original, yes. So that is what happens in assignment. In shallow copy, new outer list, yes. Nested lists copied, no. They are shared. So nested objects shared, yes. Changes in the outer list affects the original, no. Changes in the nested list affects the original, yes, because only inner nested list is shared. In deep copy, new outer layer, new nested list, which are copied to the new list, and nested objects are shared, no. Changes in the outer list affects the original, no. Changes in the nested list affect the original list, no. That is how you can remember the comparison of assignment, shallow copy, and deep copy. So this particular thing is very important when it comes to interview, because many of the people ask what is the difference between assignment copy as well as shallow copy as well as deep copy. So you can just uh, for remembering you can just say assignment, two students share the same bag. That is how it is. Shallow copy, there are two different bags, but the books inside are shared. Deep copy, the bags are different and they also have a separate books. That is how you can remember that. So for practicing the list, we have some programs over here which you can do at your home. Finding the largest number in the list, finding the second largest number in the list, removing the duplicate while preserving the order, reverse the list without using reverse function, using indexing, count frequency of each element, merge two lists, split even and odd numbers, sort without sort function, basic logic, then flatten the nested list, rotate the nested list, find the common element between two lists, create multiplication table using nested list, implement small to-do list manager, and also read student marks into list and calculate average, highest and lowest score. So these you can practice at your home. So thank you all for listening lists, and we can meet with tuples and sets in the next lecture. Have a great day.